Hello friends, welcome to our channel. Today I will discuss regarding on address, that is some address instructions. Okay, different kind of address instructions are there. Today I will discuss that is three address instructions. Okay, so three address instruction different address instructions are there. One after one I will discuss that is different address instructions. Today I will discuss three address instruction. But think that what are the address instructions are there, how to define. Whenever we go through any kind of instructions, the instruction depend on that is how many number of operands we use. Based on that, that is we can define that is that category of address instruction. For example, suppose we go through add like a R1 R2 for example. Okay, that means the addition of two operand or two numbers or two data, that is contain R1 and R2. R1 contain R1 keeps one data, R2 keeps another data. Sum of content of R1 and R2 store in R1 or R2. Okay, this is the basic concept whenever you go through add R and R2. Similarly, whenever you go through that is suppose add that is R1, R2 and R3. So in this way three registers are there, two register contains the data and another register just a destination, and we will consider this is a source, another is a destination. The sum of data R2, R3 store in R1, or reverse case also R1 and R2 store in R3. Like this we will consider. This part I have already discussed in last class. Okay, whenever you go through three address or any address instruction, we have to see that how many operands we are taking. Based on that, that address instruction we can define. If we go through this one, there is a two address or two operand, so we can tell as a two address. If it is go through this one, then we can tell as a three address. So in this way different address instruction we can define. Since our topic today is a three address instruction, then we can that is go through three address. But what are the how many types of address instructions, that we have to discuss first. After that we will go through a particular address, that is three address instructions. Okay, so different address instructions are there, like 0 address, 1 address, 2 address, 3 address. Okay, like these category of address instructions are available. Okay, these addresses are available. That means that is if you go through three address, that means three operands are required, like this add R1, R2, R3. Three operands are required. Similarly, if you go through two address, okay, two address means then two operands are required. If you one address, only one operand is required. 0 address, that means we just another concept or approaches is there, that is without address we can operate. We will go through that. I will discuss that part later, one after one. Okay, how it is defined, either that is 3, 2, 1 or 0, that we will discuss. So one after one we will discuss different address instructions. Now we will start, that is address three address instructions. Three address instructions are required minimum 3 operand. Okay, they will be kept that is 3 data. Let us consider first we will consider the one example. After that we will discuss how it is defined through three address instructions. Okay, so now we see, so let Ax is equal to A plus, very simple example. We will consider Ax is equal to A plus B into C plus D. Very simple example. Here you see how many number of that is operands. You see, very simple. Operands are, okay, what are the operands? A, B, C, D. 4 operands. And operator, how many operators? That is 2 operator, plus and that is X. Here also if you go through X operands A, B, C, D and also X also here, that is 5 operands are here. Operators are this one and another is equal. Don't worry about equal, but operation only use operators use only plus or multiplication. That kind of operators you can use. Then now we will see that how it will that is expressed through 3 address instructions. Okay, how to define. So now we will start this particular expression through 3 address instructions. Now see, very simple way. The expression is given in this way, that is x is equal to a plus b into c plus d. The expression is given in this way. Okay, no problem. That is this is given. But whenever you convert this into 3 address instruction, then how to define? First of all, you see, we divide that particular instruction into number of parts, by which we can easily identify or to make that different instruction which having 3 address. Like first of all, we will go through this one first. Next go to this one. So we can write this one first, second. Okay. After that, what happens? After completion of this a plus b and c plus d, then combine, that is this multiplication of 2 operations. That is here is 3. Okay. Next, what happens? What are the data or what are the operation after all? Then what happens? That data transfer to where? This x, like this. If you understand this kind of operation, then it is easy to find out how the 3 address is defined. Okay, for this particular expression. This expression is given in this way. This arithmetic expression is given in this way. How we will define this expression into 3 address instruction. Now we will start. So first case, one case, what you will write? That is addition of 2 numbers. So very simple, add, we can write one register we can take where it will store some data, and where operands are AB 2 operands, and sum of that 2 operands store in R1. Okay, store in R1. That means how to define? Means R1 is equal to, or R1 sum of data, that is here is memory data actually. Here A means what I already told, if x, y, z excluding register, then other data normally used through memory. So memory of A, memory of B, or content of A and B through memory. Okay, add and store in R1. This is the basic concept. And the first case is over. Second one, you see, that is add. Okay, and since it contains R1, so another register also we can take, that is R2 for what? C and D. Okay, R2 for C and D. Then what happens? R2 similarly, R2 it contains, that is memory of C plus memory of D. Okay, so content of C and D, sum of content of C and D store in R2. Okay, so R1 work is over, R2 work is over. Then what happens after that? We just multiply of 1 and 2. That means 1 contains R1 because sum of data store in R1. Similar 2 contains R2, means sum of C and D data store in R2. Only you go through R1, R2 for next further steps. No need to again write A, B or C, D like this. Then what happens after 1 operation and 2 operation? Then you will multiply. So third operation is multiply. So mul. Okay, multiply of x, multiply. What we multiply? R1 and R2. Not go through A, B, C, D. No need. That is multiply. That is what happens? R1 and R2. After multiplication, then what happens after multiplication? Transfer the data to x. So we can write x. Here we can write R1. Here is R2. Okay. So R1 and R2. Very simple way it is mentioned. So here we can write, if we go through this one, then very simple way it can find out the memory data x, it will receive. Okay, it will receive what data? R1 multiply with the R2. R1 multiply with the R2, that result data store in x, which is available in memory. Okay, so here very simple way we can go through. If it is a 3 address instruction, it is a 3 address instruction because here 3 variable we will consider always, 1, 2, 3. 3 variable we will consider, or 2, 3 operand we will consider. Then we will do accordingly. whatever the number of data is given, if this kind of data is given, how it is convert to 3 address instruction. So, it is a very easy and easy process to that is convert 3 address instruction. Okay. So, I think all of you understand this part. So, very simple, it is not so easy. Always try to convert the 3 operand or 3 address mode, R1 AB, R2 AB. R1 2 register we consider, R1 for A plus B, R2 for C plus D, and X is the memory data, and store the data R1 into R2. In this way we can consider this particular evaluation or this kind of expression and convert into 3 address instruction. Okay. Thanks to all. I hope all of you understand this particular problems or this particular topic, that is a 3 address instruction. I hope all of you understand this particular topic. Okay. Next lecture I will convert, or I will explain, that is 2 address instruction. Okay. Thanks to all.